Hello everyone, my name is Kadircan Karacan. Today I am going to talk about my Physics 101 project. My project is about the coefficient of restitution, which is basically a measure of how bouncy an object is. The main motivation behind this experiment came from a single observation in squash. A cold ball is hard to bounce, but once it warms up, it bounces incredibly fast. So I wanted to scientifically measure this. My aim was to determine how two factors, temperature and the surface material, affect the energy loss during the collision. I compared the temperature-sensitive squash ball against a standard table tennis ball. To test this, I designed a controlled drop experiment. I used a 50 cm ruler fixed vertically. I dropped both balls from a constant height of 50 cm onto three different surfaces: wood, metal, and hard plastic. I repeated the experiment at three different temperatures: cold, ambient, and warm. To achieve this, I used water to cool the balls down to about 20 degrees and warm the water to heat them up to 28 degrees. For accuracy, I recorded the bounce heights visually and verified the timing using the 5bucks app on my phone. So, what did the data show us? The results were quite distinct. The squash ball showed a massive sensitivity to temperature. When it was cold, it lost most of its energy. But as I increased the temperature to 28 degrees, its rebound height doubled on the wooden surface. This confirms that the rubber polymers become much more elastic with the heat. In contrast, the table tennis ball remained very stable and wasn't really affected by the temperature changes. Regarding the surfaces, the metal plate consistently proved to be the most elastic surface, absorbing the least amount of energy compared to wood or plastic. Of course, there were sources of error. The biggest challenge was parallax error when reading the height by eye. Also, there was likely some heat loss in the few seconds it took to move the ball from the water to the drop zone. In conclusion, this experiment demonstrated that bounciness is not a fixed property. It changes significantly with the environment. Now I will leave you with the footage of the experiment demonstrating these drops. Thank you for listening.